Welcome everyone to the April 14th OMR Architecture Meeting. Today we have two topics to discuss. One is a presentation from Mark Studley on the latest in JitBuilder 2.0, and then some extension work to the PR testing to be able to test build flags from DevNeat. So Mark, whenever you're ready, you can take over the screen.
All right. Hopefully this will work.
So far, so good.
Everyone see that okay?
Yep.
Okay. So today I'm going to give an update on some things that have been going on with the JitBuilder 2.0 library. So if you recall, I've been going through an exercise of redesigning the JitBuilder library that's in Eclipse OMR and trying to bring new features and new capabilities to it and expand it to become a fully fledged compiler IL. I've talked about this a couple of times at the OMR Architecture meeting before, so I'm not going to rehash through all of that stuff, although there have been things that have changed, obviously, since I talked last, but I did want to focus on a few things. First, I'll just give a sort of brief refresher on the goals, and I've changed the order of some of these things to reflect how important I've been treating them. Although it's not a fully prioritized list, I wouldn't say. So the main goals here are to enhance the capability of JitBuilder to make it a fully fledged compiler IL, as I mentioned. I am trying to maintain the flavor of the existing API, and for that, I really want sort of the primary use cases that I expect people to be using to remain straightforward and easy to write. However, one change since the last time that I've talked is that I have abandoned a little bit more completely the strict compatibility with how the existing JitBuilder APIs work. But I'm still trying to avoid making dramatically weird changes to the API. So like I say, it still has the same flavor, but there's some things have been kind of moved around a lot, and there's been a lot of refactoring. And primarily that's been to make better progress on the next bullet point, which is that JitBuilder 2 is supposed to be more easily extensible and be able to have people add their own types and their own operations of fairly arbitrary complexity. And so it was thinking harder about how to make this part of JitBuilder 2.0 work better that resulted in me taking a backward step on backwards compatibility. And I will get into more details on this in the talk. I am trying to increase the focus here on creating unit tests to validate correctness as I go. So I've added this one to the list from since the last time I presented this. This essentially comes from a desire not to get stuck in the same way that the OMR compiler got stuck with a lack of unit tests and a seriously large amount of code that made it hard to write a unit test suite, or at least a lot of work to try to start building up a unit test suite. So I'm trying to do more of that work as I go now, so that there is a body of regression tests, as well as in some senses they're code samples as well, but just validating the correctness of the things that I'm building. And then finally, improving usability. So, over the years that JitBuilder has been used, there have been a number of, well, I'll call them complaints because they really are, about the way that JitBuilder works and how it's not always easy to understand errors when they happen or figure out what it is that went wrong and how to fix it. So I'm trying to fix some of that by, in part by making it a more fully fledged compiler IL. You get things like introspectability, printability, and so on. But I'm trying to improve on things like how easily verifiable it is that you've done the right thing, and improve the handling of errors so that you can understand what went wrong. And then, of course, it's a compiler IL, so you should be able to traverse it. You should be able to analyze it. You should be able to do transformations on it. And last time I was here, I talked about a debugger, which is actually in a non-functional state right now. So I'm not going to talk about that very much today. but it is something that I'm going to be bringing back, and it's I think a very important part of the JitBuilder 2 project going forward. So today I'm going to talk primarily about these ones in red, because they're sort of the areas that I've been focusing on mostly. And when I say focusing on, I was I was joking with Erwin one day a few months back about how it would be quite appropriate to codename this project Midnight, because a lot of the work that happens for this is stuff that I fit in side moments, and most of those side moments are after everybody else goes to bed in my house. So a lot of this code got written around the midnight hour. And so obviously it's taken me, a long time to put together some of this stuff, but I think it's starting to take a really good shape now. So I wanted to come back and tell you about some of it. So that's my form of an apology for don't be too underwhelmed by any of this. All right. So, oh, that's interesting. That's an extra slide, shouldn't be there. So, right. So, a bit of a refresher on some of the key elements of JitBuilder. So it's a compiler framework. So you operate on values. Values have types. You arrange operations that are being performed in JitBuilder into builders, which I liken to. It's kind of like the stuff that's between curly braces in a C or C++ program, right? It's kind of like a code path, but it's more than a code path because it can have other things embedded inside them. And type dictionaries. There's lots of new stuff that has been created as part of this update. So I didn't used to have a thing called a compiler. I'll talk about it more in the next few slides. And it carries along with it things like configs for detailing what to do, strategies, like compile strategies, compilation passes, a compilation object. Extension is one of the big new things that's there now, which is the basic mechanism by which new types and operations and capabilities get added to a JitBuilder compiler. There's a few more IL bits that have been kind of outlined here with operation and literal dictionary and symbol dictionary. Didn't used to have symbols. Literals didn't have a literal dictionary before. Same kind of analysis and transformation as I've talked about previously. Obviously, the debugger is non-functional, but it will be present. There's these things called JB1 code generator and method builder, which are used to help actually generate code using JitBuilder 1 from JitBuilder 2. I guess it's a little bit of a sign that I haven't really thought through very well this whole code generation notion here, that it has specialized code generators for JitBuilder 1, but nonetheless, they work. And then a text writer is the main feature by which you get textual information of representation of the IL. Okay, so I've started kind of dividing up the bits and pieces of JitBuilder 2.0 into different pieces. The first of them is kind of a core library. So I've, as part of this sort of quest for extensibility, you can't start from nothing. So I've created a thing called the JitBuilder core library, which really contains a lot of the very, not necessarily abstract, but it doesn't have a lot of sort of hardcore things that you can use in it directly. Although it does have compiler in it, which is something you do use directly. It has extension, which is a base class that you use quite extensively when you're extending things, and so on, as well as all of the IL components like builder and compilation. So let's just kind of look through these things a little bit. So there's kind of like IL components here that are sort of the basis on which the JitBuilder 2.0 IL is constructed. And a lot of these are familiar concepts for people who've used JitBuilder before, or even for people who've just worked on compilers before. Builder, as I mentioned, it's kind of like a code path. Location is a way of specifying source code locations and passing them, identifying parts of the IL with the source code location that they came from, and etc. And there's a bunch of infrastructural components that are, like symbol dictionary holds symbols, a literal dictionary holds literals, a type dictionary holds types, those kinds of things. Sort of baseline transformation things like visitor and transformer patterns for writing things that change, the IL or for processing the IL. Compilation, strategy, and pass are things for assembling a sequence of analyses or optimizations to be performed on the IL or to process the IL. And then other sort of more basic things like config for providing ways of specifying configuration data, creation locations, which you'll learn a little bit about later on in this talk. And again, the sort of more fundamental things of compiler and extension, which I'm going to go through in more detail in this talk, so I'm not going to talk too much about them right now. And then there's the JB1 code generation stuff as well, which is kind of locked in here into the sort of core facilities of this library. So let's see very much here. Yeah, so the core library here, when it gets built, actually builds together with JitBuilder 1. There is actually a class called JB1, so that is a class, not the JitBuilder 1 library itself. But in fact, when you build libjb core, it actually loads or it also includes libjitbuilder.a from the JitBuilder library. So this one's actually quite a large one, but in terms of JitBuilder 2 ability, it doesn't define any specific operations that you can use. It doesn't define any specific types that you can use. It just defines how the IL kind of fits together. So it's kind of like, from an OMR compiler standpoint, it's kind of like a combination of the IL, bits of the IL directory, sort of the core pieces of the IL directory, plus compile and infra and all of that sort of stuff. And then, right, so let's start talking about some of these. So I mentioned that compiler is kind of an important one, and it's an important new one. So the API, I've kind of replaced the use of initialize JIT and shutdown JIT as APIs that users will use. Instead, I've kind of wrapped that into an object called a compiler object. And you can actually create multiple ones, although they're not currently synchronized, so you got to be a little bit careful when you use them. The first time you create a compiler object, it will end up calling initialize JIT, or I guess rather, I should have said is if there's no other compiler object currently alive, it will call initialize JIT, and if the last compiler object around, if it gets destructed, it will call shutdown JIT. So that's how it interfaces with JitBuilder 1. And they're very easy to create. You just kind of do a compiler C and then give it a name. And like I said, you can define multiple of them and you can configure them differently. A compiler object basically has a lifetime that extends across all of the compilations that you would do with it. And there are some things that it carries around with it, like a config object, so that you can make set configuration options that extend across all of the compilations that you would do. You have a type dictionary so that you can define types that will be visible to every compilation that you do. It has a set of loaded extensions, which I'll talk about in a minute, and it has a set of named strategies and named passes that are typically created by the extension objects and added into the compiler so that they can be used by anyone who's doing a compilation on that compiler. The basic idea is it's designed to allow multiple compilers to be constructed dynamically in the process. Different kinds of compilers. So you can imagine a language bytecode compiler, you could have a regex processor, you could have a SQL engine, you could have all of those different ones, and they could all be leveraging JitBuilder 2, the same JitBuilder 2 library, but they could be defining different compiler objects, which could then have different extensions loaded into them, etc. At the JitBuilder 2 level, different compilers don't really have very much of a notion of each other. So, one compiler object isn't really aware of any other compiler objects that are there. But obviously, because it's all leveraging the OMR compiler under the covers via JitBuilder 1 library, they're all putting their generated code into a single code cache repository, and they're all leveraging the same compiler infrastructure under the covers. It's just a matter of how the IL gets kind of generated and put together. And as I mentioned, it's also an object that has a life cycle that spans longer than all the compilations. And note that compilation is now a fully fledged thing in JitBuilder 2 as well.
Mark,
extensions. Sorry,
Sorry,
there's
is
a
that
question.
code cache repository? Is that synchronized?
No, because it's the OMR. It's just the OMR compiler. It's just the OMR compiler providing that.
Okay.
So right now the OMR compiler doesn't have a notion of different threads. So if you create threads and use them to access the OMR compiler, you have to manage all of the synchronization for that right now.
Okay.
It's one of the limitations of the OMR compiler right now, which sucks, but it would be great to fix. And I think it's one of the things that we will ultimately end up fixing here. All right, so extensions, plug new things into a compiler. So as I mentioned before, libjb core doesn't really define any concrete types or operations to be able to do anything. So as a library, it's not all that useful by itself. And I did that actually purposefully because I wanted to put pressure on how easy it was to extend and add new types and operations. If I provided a whole bunch of base types and base operations in libjb core, there wouldn't be as much pressure on making it easy because it would only be kind of extra stuff or stuff that's outside the project that ends up using those facilities. So I didn't want that to happen. So I decided to keep everything very abstract in the core, and everything else, even the support for the traditional types and operations that you would use as part of JitBuilder, the JitBuilder 1 library, you have to get it via an extension. And so that's where this extension class comes in. It's a subclass that you can create extensions by subclassing. And the most obvious example of that, what I've got right now, is I created a namespace called base, which has a base extension class, which is where all of the JitBuilder 1 operations, types, symbols, etc., are being defined and are loaded into the compiler. And that process is not complete. It's actually a relatively small set of things that are there right now, just because, again, I haven't had a whole lot of time to work on this, and B, it's the additional focus on trying to test everything as it goes in slows down the movement of stuff. But nonetheless, it's got enough to do matrix multiply right now, my famous example. And it also has supports for structs and pointers and things like that. So the way you use these things is, so when you're creating an extension, you basically, the typical use case here is that you're going to build it all into a shared object, which can be loaded dynamically, and it relies on you implementing a create function, which is the thing that gets the compiler will look up when it asks to load a particular extension. It will try to call that extension's create function, and all it has to do is return an instance of the extension. So different compilers may call this multiple times and get a new extension object, which is tied into their compiler. And the way that you actually do that is relatively simple, right? There's a load extension thing on the compiler object, which you can call. You give it the type so that it knows how to cast it properly, and then you give it a name, which corresponds to a name that you've defined inside the extension. Extension has to have a version, and it has to have a name. So that name that I mentioned up there is base, but if you're creating your own extension, you can give it its own kind of name. Typically, this name is what you would have in the lib, like the base extension is called libbase.so. So this would be libmyextension.so, and that name helps the compiler automatically look up where the library is and load it, etc. It's kind of a convenience thing. It doesn't have to be done this way, but this is the way that I've kind of consistently done this, is that there's a semantic version class that I've implemented as part of part of JitBuilder 2, which extension relies on having. So you have to have a version of your library which you maintain. And then the load extension function that I showed on the previous slide, you can actually specify a particular version if you depend on a particular version of the library. And according to the rules of how semantic versions work, it will ensure that it only loads a library that's compatible with the version that you need to load. Not equal necessarily, but compatible from a semantic versioning perspective. All right, so that's how you create extensions. And how do you create actual types? So creating a new type, you just do a few things here. So obviously you have to create a subclass of type, which I should have changed the typeface on. So as an example here, we could create my type class. And then there's a number of functions that you need to implement from the base class type that helps kind of specialize how that type will be used. And I expect this number will grow, but right now it's at about 8. Some of them define a few extra ones, so it's like 10, but they're generally speaking quite simple little functions that need to get implemented. And there are things like print literal, are these two literals equal? If it's a numeric type, what does a zero literal look like? And that should be identity, not identify, sorry, etc. So there are just a number of these little functions that you have to go and implement for a type. And then you add a public field to your extension class, and our example here is my extension, to hold an object of that class type. So here's this const my type class, my type, right? And then it needs to get initialized as part of the constructor for the extension object. And there's a way to do that. So the my type field gets initialized by calling register type, which is something that's defined by extension in your subclass. And you pass it a my type class. And I'll talk a little bit about this loc thing later on, but basically this is a source code location that helps with error handling if anything happens to go wrong. All right, and beyond that, you can specialize your type any way you want by adding, other things into it, but there are a few things that you have to implement in order to define things. So these are how things like int 8, int 16, int 32, int 64, float 32, float 64 are the new float and double. So I decided to sort of make that more consistent in terms of expressing the names and etc. So all the primitive types are defined this way inside the base extension. One thing to point out is that all types are now const pointers. So it's impossible to modify a type after it's been created, which is kind of why I have to do this crazy thing during the constructor here. But it does mean that types are now nicely const throughout the whole. You can't do anything with a non-const type, basically. You can't get access to one even. Change it. All right, so once you've got types, you can create values, but you need operations to actually produce values. So how do you add new operation types? It's actually quite similar to creating a new type. You have to create a subclass of operation in this case, or one of its subclasses. There are actually a bunch of structural subclasses of operation that are created to help make this easier. So for example, there's a operation R0v2 is an operation that doesn't have any results, but it has 2 values. And so it provides some of the basic implementation needed in order to access the values of that operation. And if it had results, then what results it would have, if it had symbols, if it had types, etc. So, depending on what kind of operation you're defining, you can probably leverage one of those structural subtypes, or you can just go back to operation and define everything yourself. Operation defines the very generic API for accessing an operation. There are right now about 3 functions that you need to implement in that class. There's a protected constructor. So I think I talked about this in the last update, that the JitBuilder 2 doesn't let you directly create operations yourself, operation objects yourself. They are created by another class, and I'll talk about how that happens in a minute, because that's also one of the things that's changed in JitBuilder 2 versus JitBuilder 1. You also have to implement a cloning operation. This gets used by things like the debugger and others, and the type replacer, for example. And then there's a JBGen function, which allows the operation to generate JitBuilder code. So this one leverages the JitBuilder 1 JB1 code generator and JB1 method builder, primarily the method builder class that's implemented in libjb core, and so on. So you also have to add some public bits into your extension class so that people can figure out how to use this operation. One of them is a thing called an action ID. So now that operations are completely dynamic and not sort of statically embedded into the language, it's not an enum anymore that you can use. So it's It's actually just an ID number that gets assigned by the compiler. The compiler assigns actions as you register operations. And so you need to store what that number is that corresponds to a particular operation. And then you need a function that allows you to actually create operations of this type. So it's the extension object that creates operations. In JitBuilder 1, it used to be a builder object. So on the builder, I'll show an example of this in a minute, but you used to call operations on a builder object and pass it operands. Now you call the operation on the extension object, and you also pass the builder object into which it's supposed to be injected. And this little bit at the bottom here shows again how that action ID gets assigned. Register action is something that's defined again in the extension base class, and you give it a name, and it just hands back a number, and the compiler just tracks. In the end, the compiler is tracking how many actions have been created before, and it just gives you the next ID. It keeps giving you the next ID, and then it gets assigned to be used as part of this particular operation that you've defined. So yeah, right. So I'm trying to give here sort of the showcase the sort of difference between how things used to work in JB1 and how they now work in JitBuilder 2. So in JitBuilder 1, you would access types from basically cached versions that are stored off of the TRIL builder object. So there's just int 32, float 32, whatever. You can just access them directly from when you're writing your code that's accessing these operations. Sorry. When you're accessing the code that's accessing these types or that needs to use these types, you can just use them as names because they're provided already in the base class of the thing that you're extending, which is an IL builder object. Other types are also maintained inside the type dictionary, so you ended up passing type dictionaries around everywhere so that you could get access to the types that are inside them. Operations, as I mentioned briefly, are done off of the builder object, right? So if you've got some builder object here, TRIL builder object, and you want to add one to a particular value, you can do something like this, right? You can on the builder, actually, so on the builder you would load a variable called value, and that would return a TRIL value. You can create a const 32-bit integer of 1 again in this builder object, and then you can take those two values and create an add operation again in the builder object B, and then you can do B return of this repval guy. Now you're creating operations directly inside the builder. So if I need to inject an operation into a particular code path, I just find whatever builder object corresponds to that code path, and I call the operation on it, and it just injects. It actually appends onto the end of that code path what the operation is. In JitBuilder 2, you're now mostly accessing types and operations from an extension object, which is the extension object that owns or created those types and operations. There are still type dictionary objects that hold types, but they're a little bit less commonly used, I've found, at least in the very small number of code samples that I've done. So at this point. So here again, you got some builder B that is it's the code path where these operations are supposed to be injected. JitBuilder 2 now uses symbols rather than strings to refer to variables. So you'd have to use define local, and it would hand you back a symbol that you could store as value sim in this case. And then we've got some base extension pointer to the base extension called base. And so now, first of all, we load the value symbol in the builder B, and then we access to that load via the base object. Same thing. There's actually a simpler way to do this, and there's another mistake on the slide. So I've defined something called a pseudo operation called increment, which actually expands out into take a value, add something to it, and give it to you back. So it's sort of an easier way of accessing something. This should really be identity, not zero, because adding 0 to something is probably not very valuable. But that's a mistake. Anyway, you can ask a type for its 0 or its identity value, and you can just add it to the you can just use it in in these operations. And then finally, you can do return the same way. This should be new val, not rep val. Wow, lots of bugs in this slide, sorry. Okay, so the target builder here, whereas it used to be, the receiver object for all of these, it's now just a parameter that gets, an argument that gets passed in. And there's this loc thing that's kind of sprinkled throughout as well. It's being passed into every one of these operations. So loc is a way of identifying this code location, so this code location in this source, the compiler's source code. So it's not a concept that corresponds to the code that you're compiling, but the actual code of the compiler that you're writing. And so this loc is just really a macro that expands to the file name, the line number, and the function name, and it consistently passes that down through all of the implementations so that you can get access to where this line of code is if something goes wrong, right? So if you pass the wrong kind of symbol here or something, I don't know, something you couldn't load, for example, it's probably a bad example, but something you're not allowed to load, and down in the depths, the guts of trying to create that operation, it discovers that that's not valid. It can know where this line of code is that created it and tell you about it. I'll give you an example of that here. So as I said, it's a pound define. It just kind of uses preprocessor macro magic to get all of this information. There are also some additional macros for that, so this is what you put when you're calling something. This is what the location is what you use when you're defining a function. So it expands out into 3 parameters that have the right types for receiving these values. And then pass loc is a way of passing the location that got passed in for a function to another function. So you're not trying to get the location that's inside the function, you're trying to get the location that was passed into this location. So anyway, so these become very easy to use after a while. You get very used to them, and it makes it really easy to pass the location in around. And it means that you can get really useful error messages when you're working with these things. So as an example, here's one of the tests that runs as part of the sort of regression testing for the base extension. This is testing for the add operation. It's verifying that if you provide types that are not valid for an add operation, that it will throw an error. And it uses an exception to throw back the error, and then it has an error code that's specific to what happened here. So it doesn't actually assert anymore, which is one of the things that the original JitBuilder library used to do. Is kind of you're kind of stuck if the thing asserts, because it just asserts and dies. There's no way of kind of recovering from that. So rather than having a model where everything asserts, I'm trying to modify everything so that they throw an exception and return a value that can then be inspected. And as part of the exception object that gets passed back, there's a message that gets, sort of assembled at the error point, and it can say, in this case, you have had an add operation that had invalid input types. It tells you what the left type was. This is the type identifier for it, what its size was, what its type is, and what kind of type it is as a primitive type. And the same for the right. And then it gives a little explanation. Left and right types are expected to be the same for integer types. So obviously these are not the same. Integers also not quite the right thing to say there, so I can improve that. And then there's also this other point that is, if one of them is address, then the other one should be whatever the word-sized integer type is for the platform that you're running on. So it gives you a little error message, and this is something that can be printed out. It can be not printed out. You also get an error code that corresponds exactly to an add with invalid input types, so that when you come back from trying to compile a function, it will tell you that this is the error result that you got. And it's the same kind of mechanism that I showed for types and operations. The compiler error codes are things that can be extended by an extension to say, these are the kinds of errors that my extension operations can throw, and features. So it makes it a lot easier to find, where this line of code is and go and fix what's going on there. As I mentioned, I'm trying to improve a lot the testability of things and how much things get tested. So I'm leveraging the Google test from OMR to do that. The intent here is for building up tests for everything as JitBuilder 2 gets augmented. So it's, as I said, it's one of the reasons why progress has been slower, because writing tests is not always as straightforward as writing the code in the first place, especially if you're just porting something across, but you don't have tests to port across. It has found some bugs during, through that process. So I think it's clearly been worthwhile as an exercise. It means those bugs didn't hang there latent, waiting for me to find them in some more complex scenario or have to debug them in some more complex scenario. Although I'm not 100% happy with how all of these tests are written at the moment. So I think this is one area where some improvement would be quite valuable. In terms of what's being tested so far, so I mentioned there's that semantic version class. So I did write some tests to verify that it correctly identifies compatible version numbers. The whole compiler creation and destruction thing, properly initializing JitBuilder 1 and the OMR compiler, at least from the point of view of calling initialize JIT when it should and calling shutdown JIT when it should, that's been tested. The code that loads extensions by name and verifies that it works when there is an extension that it should have. It won't load the same extension twice. It won't, sorry, if you try, actually I can't remember what I did there anymore. It just hands back the existing extension because it's already there. Anyway, it does verify if the extension object's not, sorry, if the library for the extension isn't found, that the proper thing happens and it returns an error code, and etc. And then for base extension, I've written a fairly large, extensive number of tests there, which test both positive and negative things. And again, having that return code that tells you what went wrong allows you to do a good job of making sure that you're properly validating the IL that's being created. So it's currently the test base, which is the one that tests the base extension right now. It counts 242 tests, but that's really over 1,000 tests because there's a lot of expect tests that are happening inside each one of those tests that Google Test is counting. And I believe it's testing all of the combinations for add, mul, sub, and for loop, all of the different type combinations for the values that you can pass in. It's verifying that the ones that shouldn't work don't work and the ones that should work do work, as well as testing the function of those ones that should work to make sure that they do the thing that you expect them to do. There's also in the base extension, it defines a pointer type, which allows you to do load at, store at kind of things. There's a struct type, which is also tested with a variety of different kinds of fields, make sure that you can store to one field and it doesn't affect the value of other fields of varying types. It also, creating recursive types is an interesting challenge when all types are const. So there's kind of a builder notion that's been that I've introduced for creating struct types and pointer types that allows you to basically it provides a mechanism for being able to define a type that refers to either itself or to another type that hasn't yet been fully defined yet. It's kind of an interesting thing. So there's like a struct type builder and a pointer type builder that you can use to construct types that are fairly complicated. And that's all been tested. All right, so at this point, I am going to try share a different window. Stop sharing that. Figure out how to share this guy. All right, and you can see that things don't quite work yet. This is the top level directory of the JitBuilder 2 project right now. So it has all of those things that I pointed out on one of those slides. There's a makefile in it. To make it is very easy, just make libjbcore.so. I'm not going to talk about that very much. What I did want to go and do is first I wanted to go into the samples directory, which has this map mult thing, which currently doesn't work because you can see the compile failure right up there. So there's actually an issue at my repo for this that I opened just before this talk because I discovered this recently. Hold Or do you want to do this? All right, so let's look at the main function here, because it kind of helps you get a feel for what you need to do in order to use JitBuilder 2. So the first thing is, and I apologize, this doesn't leverage OMR, and it is only going to work on certain platforms. I've been working primarily on Ubuntu, so it's very specialized right now. But the basic thing here is, this will get fixed. But for now, it's a very kind of Linux specific kind of world. So we load libjbcore.so so that we get all that code into memory. And then if you want to do compilations, you have to create a compiler object. So we create a compiler. This is the matrix multiple sample compiler. Typos everywhere. And then the next step is to load the base extension, which is, I kind of showed this code in the presentation already, so it should be quite familiar. If it returns null, obviously it couldn't load that extension, so you can deal with that. And then I wrote this code, this multiply code, so that it could actually work on any type of dense matrix data. So in this particular case, I'll show you what this looks like right now, but essentially it's saying this is going to be a dense matrix using the float type of float. And that means you need to use this particular function to implement it. It uses the base extension. This is the JitBuilder 2 type that corresponds to float. So there's a little bit of user, craziness here. There's an init matrices is just an initialization function that initializes a float array properly. So there's some quirkiness here, but it's the core stuff is actually kind of interesting. So this is that template here. Right. So you handed it a compiler, a base extension object from which we can get the compiler. It's going to initialize the matrices of the appropriate type, right? Calling the init function to do that. You then create a function. So in JitBuilder 1, this would have been a method builder. It's now called a function in JitBuilder 2, and the function is not itself a builder anymore, but it has an entry point that's a builder. So all of the sort of guts of compiling a matrix multiply routine is sort of passed in here, and it gets some parameters to tell it what kind of function it's supposed to create. You can do a bunch of, and we'll look at that in a second. You can do a bunch of logging and so on with by creating a logger a logger, a text writer object, and then registering it against the compilation that's associated with the function. It's a long string of connections, but anyway, you can basically get textual output of the thing as you're running it, and then you just call .compile on it to compile it. In this particular case, you're handing it a log, so it will print out on the in this case on standard out, or C out, because that's the one we created it for. It will do the compile. With compile successful, then you can ask the function for its native entry point, which is what this guy does, and then you can call it, and it will hand you back the right results. All right, let's take a look at what this matmult guy looks like, because he's got a, just like in JitBuilder 1, the constructor defines what the API is for the function, and the build.il function defines what operations to perform. That still exists in matmult. So let's go find that guy up here. Okay, so here is the constructor. So again, defining the API. So this looks very similar to the way it would have worked in JitBuilder 1. Nothing really changed in terms of being able to define the source code location for this, the name of the function. Defining parameters and defining locals, as I mentioned, you have to create symbols now, and you have to know what those symbols are in order to access them. So all of the define local and define parameter functions from JitBuilder 1 now return a symbol. Try. Oh, what's that? Can't see anything anymore. Sorry. I've done something bad. It's too bad. All right, does that help everyone to see better? It doesn't help me though, because I can't see anymore. There. All right. Does that help people? I can't see if anybody's agreeing to me, so I'll assume that it does. Right. So define things like define parameter and things like define local now return a symbol pointer, which you can just kind of scroll off into your object so you can remember them and access them later. And again, the purpose of this, of the constructor of this function is to define what the ABI is to, or what the parameters and what the return types are for this function. And so that's what we're doing. Define parameters, we're defining return types. There is a sum local that gets defined here as well. This doesn't have to be done in the constructor. It can be done later on, but we did that. Okay. And then the other piece gets done in build.il. So this is the code that specifies what operations should be performed when this function is called. So as I mentioned, the function itself is no longer a builder object. So in JitBuilder 1, you used to just start calling operations and they would be injected as at the call, at the, when it gets called, those operations are the first ones that would get executed. Now you have to ask for the builder entry of the function, and that gives you a builder object, which you can then use to pass to other operations to do things. So I mentioned there's some source code location handling here. So source location is the way that you can start passing in things. So this one creates a source location that just has a function name. So mapmult as the function name by default. So I don't actually leverage this source location stuff very much anymore, but it does start off by creating a source location for everything. In principle, you could do this at any point throughout this whole function, and the operations that follow that call to source location would have the updated location attached to them. All of the operations that you perform then just become calls off of the base extension, and you end up passing the builder object that you want to do it in, and passing obviously the location. So we load all of the array pointers, we load the size of the array dimensions, we create 0 and 1 constants using the base extension to get those. We're creating those as int32s in this particular case. So these are used as part of the for loop counting, just to simplify that code. And then I've mostly managed to, I don't know if you can see all this, but this is basically the code of the 3 loops of the matrix multiply. And I've kind of used a stylistic way of writing this. When you create a for loop op, I open a curly brace so that this is the code that should be the curly brace doesn't cause anything to happen other than it creates a scope. So it's still up to you to make it to do it properly, but it's a visual aid to being able to check to see if you've done it properly. The other change that I've made here is that for loops now actually return a thing called a for loop builder, which makes it a little bit easier to work with them. So you can have you basically pass in the parameters of the for loop iteration. So this is a for loop in builder B that will iterate on a symbol called sim I here, which is the one we just defined. So it's going to use I as the iteration symbol for the symbol over the variable over which you iterate. And it's going to go from 0 to n by 1. And then it returns this for loop builder object. And from the for loop builder object, you can get to access to things like the builder for the loop body. Or if you need to call break, you can get a builder that corresponds to the break label or to the continue label, so that you can direct control flow towards those parts of the for loop. And basically, the for loop builder object gives you all the information about the for loop that you can query. You can also get access to the iterator, like all of these things. You can also access from the for loop builder itself. So here we can load the value of I in this loop. So anything that uses I from this point forward will be using the current value of the iteration variable, right? We got I loop variable. And then you can just kind of flow on. This is the outer I loop, this is the middle J loop, and this is the inner K loop that does the dot product here. The extra special thing here is the initialization. Because you're doing a dot product, you have to initialize the sum to a 0, so it just uses 0 on the appropriate type to get it, and then initializes the sum symbol with its value in the JBody loop, and then in the K loop you go and do all of the loads and all of the stores. And I've kind of created helper functions, which you may have noticed as I was scrolling around, to create the two-dimensional load of A of I and K, B of K and J, and then it multiplies them together, and then does an update on the sum inside, and then does the store 2D on the outside in the middle loop to store the result of the dot product after it's produced it. Now, I've done this myself. Maybe I'll go and find one of them just to show you what it looks like. Right. So here is the load 2D and store 2D. So they're basically just doing multiply first by the row size, add the second index, and then index into the array at that location, and load at that pointer. So this is something that I've done in the code sample, but obviously I think it would make sense at some point to define a dense array extension, which would provide a load array or array load operation, which would just do all of this stuff, and then you in your code base in the code that you're generating, you just see an array load that takes in these basic parameters, so that it would know how to load from that array. And similarly on the store side. All right, I'm going to see if I can figure out how to get my screen back to normal here. Not sure what I did to okay, so I'm back. I'm back to normal. The last thing I wanted to do in this demo is to load base extension.hpp, and I just wanted to look through what this thing actually looks like. So here you can see, the versioning stuff that I mentioned. These are the types that get defined as part of the base extension. So there's one for all of the sort of basic primitive types that are there. It also defines a word one, which it automatically detects if that should be a 32 or 64-bit value. Although I confess I do not have tests to verify that right now. If you need to create a pointer type, you can use pointer2 to do that. A little bit in the earlier, in one of the earlier updates, that you can create function types directly. These are the different kinds of action IDs that get registered by this extension. So it just creates one for all the different operation types. So load, store, load at, load field, store field, load feed, field, load field at, load, store field at. You can create local arrays, create local structs. So we're kind of building up we're kind of building up to the number of operations that are needed in order to implement the debugger. That's kind of the next big user of a variety of operations. I did mention that you can add compiler return codes, so these get defined in largely the same way. There's a type called compiler return code, and you can create your own ones. And then there's all of the operations, which basically these are the kinds of things that you used to call in builders, and now you can call here. So I'll get in here, and these things I've called pseudo operations because they don't actually appear in the IL, but they help you build IL that's sort of more pleasant to read. So increment, I misused this in the presentation, but increment takes a symbol and increments it by bump. So basically it loads the value, adds the bump, and stores back to the symbol. So you don't have to create so much text to do that anymore. Different ways of providing source locations. These are helpers to create different kinds of constants, which existed in JitBuilder 1 because JitBuilder 1 didn't have a common notion of a const that you could create. It didn't have literals that are really well defined. So there are helpers here which correspond to the things that you used to see in JitBuilder 1, but really they all basically call this guy, which is a const, and you provide a literal, and this literal can be of many different actual literal kinds. So it's all hidden behind that processing. 0 and 1 I mentioned before. I think that's about it. Oh yeah, there's one other piece I guess I can talk a little bit about quickly. So the way that operation checking works is it uses an additional class called a type checker, which it's not really a well-defined thing, but you can create a class which has the code that will validate the different operations in the extension, and then also what to do if a failure happens. And so this code all ends up being embedded in the add functions. Sorry, this code will all get embedded in add, in mul, and in sub, and in for loop up. It will end up being called from there. The reason why I did this is why it gets separated out is so that if you have another extension which defines a new class, say a new type, say complex, and you want to be able to have the add operation work on complex types as well. I didn't want the complex extension to have to recreate all of the add, mul, sub, etc., and handle the complex type, and then delegate back to the base extension to handle other types. It made more sense to me to maintain the structure that the base extension has, but have a way to add more validation or better different validations into that process. So each extension has a list of extension checkers. So the complex extension can define its own base extension checker, which adds support for the complex type. And if it doesn't see a type it recognizes, then it just lets a later base extension checker do the validation. And so it eventually falls back down to the base one, and the base one will, if it fails, then it will print out the error message, etc. So it provides it's a little bit extra work, but it provides a relatively clean way of adding new things into the extension. I'm sort of testing that out right now as and creating a complex extension for the mat mult sample. Okay, I think that's the end of the demo. I have one slide left here. Sorry, I know I'm taking a long time. Be done soon. This guy. All right, current status. So there are currently some OMR dependent changes that are required to use JitBuilder 2. There's about 7 commits that I've currently got in a pull request at OMR that will hopefully be merged soon. But as of the start of this call, I don't think they had been merged. I have actually pushed the current state of JitBuilder 2 to this repository in my own user. Which people can download and fetch from. I am currently developing this. I just created it today, but I've been developing this independently of OMR, basically so that I can start tracking history and do commits and make changes to stuff without really overloading the OMR committers with changes. Since at OMR we're not allowed to merge our own changes, so I didn't want to create a whole bunch of burden for the OMR project while I iterated on trying to figure out what the heck I'm doing with JitBuilder 2. So I've taken this code and I've put it into my own private repo there. I did add a README. It does have a license. As I pointed out in the talk, there is a compile failure that I have to fix in the code sample, but that'll get fixed shortly, I hope. Unfortunately, I can't accept changes from anyone because, and the reason for that is that I need to be able to contribute this code at some point into the OMR project. And if you don't give me the rights to do that, I can't do it on your behalf. And so rather than set up a contributor license agreement or any of that kind of hassle, I'm just going to not accept changes from anyone. But that doesn't mean I don't want to interact with people. So that's the whole reason why I created the repository, was so that people would have something that they could download and have a way to interact with me on it. So if people have, if they try it out and have feedback, or if they see something that they don't like or think they could, think that would be better, I would be perfectly happy for people to open issues at that repo to interact with me. You can always reach me at the OMR Slack instance. I monitor that on a fairly regular basis, particularly in the JitBuilder channel, and or email if you want. But yeah, that's it. That's the end of the talk there. So I'll finally pause and see if anyone has questions.
Thanks, Mark. Earlier in your slides, you had some code that used standard string. I'm wondering, are you using that now in JitBuilder? I thought that for JitBuilder 1 there was some issue with the lifetime of the memory for standard strings, which is why we didn't use it.
Yeah, well, yeah. So the issue with standard string with JitBuilder 1 was because it is part of the compiler code base. The string interacts. Memory allocation handling interacted badly with for string and the memory allocators of the OMR compiler. So that was the fundamental problem there, and we never really got to the bottom of a solution there. JitBuilder 2 does not build as part of OMR, so it's a completely separate independent library. It uses OMR and it uses libjitbuilder.a, the thing that gets generated by the JitBuilder build, but it is not part of the OMR codebase. And therefore it doesn't actually leverage, and that's kind of a problem in a way. It doesn't leverage any of the memory allocator stuff that's in the OMR compiler. And that's actually something that I would like to fix. I would like to maybe not necessarily use the OMR. Well, I haven't decided that yet. I would like to have a managed memory allocation story for JitBuilder 2 before things get too much further forward. The memory allocation sucks, so I've been deferring that, trying to get things a little bit more capable, and so that people could actually try it out and do stuff with it.
I see. Okay.
So I guess the final answer there is JitBuilder 2 uses standard string quite extensively right now. I've been using standard string, standard vector, standard dec in a couple of places. So it does currently use the standard template library, but that's not I don't think there's any like baked in requirement to do that. They're just containers. So I've also been sort of toying in the back of my head with not using those containers because they carry with them a set of other problems, as we know from our work with the OMR compiler.
Mm-hmm.
Hi, Mark. It's David here. I'm curious how much the performance of JitBuilder per se matters, or I mean, of course it matters to some degree, but
yeah.
Is that the thing that we should all care about, or it's more the generated compiler and obviously the generated code that matters?
Yeah, so I mean, I guess the primary focus there is on the performance of the generated code, but because this is a dynamic compiler, we can't ignore the cost of the compiler itself. Right now, the bulk of the compilation time, I would guess, so this isn't something that I've validated, but my guess would be that the bulk of the compilation time is still in the OMR compiler component.
Right.
So I have not been focusing terribly much on the performance of the JitBuilder 2 code base itself, although I'm not actively trying to make it slow, but I'm also not really paying very much attention to it. So I'm trying to do things where that makes sense to me as I'm doing them, but I'm not really focusing on it at the moment. And that also connects into that comment about the STL containers as well.
Right,
actually.
That's what inspired my
right
query.
Yeah.
Okay, thanks.
Yeah, sure. Thanks for joining, David. Any other questions?
Okay, if there are no other questions, thank you, Mark, for that update. Looks like you're making good progress there. Looking forward to seeing that contributed to the code base.
Thanks.
Okay, so we have one other topic for today. Bhavneet, I hope that 22 minutes is going to be enough for you. but we'd like to talk about some testing, adding build flags to some of the testing that we do. So, Babneet, if you're ready, please take it away.
Yep. Thanks, Mark. First, can someone confirm if they can hear me?
Yes, I can hear you.
Yes. Okay. So thanks, Mark. After your presentation, I think I will play with JitBuilder as well in my free cycles. And moving to
Awesome.
my topic. So I've been reviewing. I've reviewed few peers recently, and it looks like we couldn't test the code in our PR builds because the code is disabled by default. So I'm proposing to add options to the PR builds so that we can enable preprocessor flags. I've shown an example over here how it will look like. But there's also an opportunity for GC and JIT, because I think I know GC has different configurations, and I'm not sure if we run all the configurations in our testing. So if we try to go with something like this, we may also add some features for GC to enable some of its configurations. And I'm not sure if JIT has something similar to add. So I would like to discuss what is the best way to extend the PR builds.
That idea doesn't sound too bad. Are the flags that we use, or the variables for the flags, are those is that a CMake flag that you have there?
Yes,
So
I think
C
it's
flags,
for
example.
C++ compiler. So it will directly go to CMake, and then CMake will send it to the whatever compiler we are using below, GCC, G++.
Okay. I mean, that seems all reasonable to me. I guess it's Jenkins, I guess, is extensible enough to allow that. I guess it is, because you can add other build triggers and things like that.
Correct. The only thing that will modify is the CMake command underneath, which Jenkins generally launches. So these options will pass all the way to the CMake command, and then it should do the job.
Does it allow, I don't know if Jenkins, does it allow optional variables there? So for example, if you didn't want to override C flags or CXX flags, can you just say Jenkins build all?
Yeah, it should still work.
Okay.
But I'm not sure if there may be security issues because you're passing a string to the machine. So we may need to sanitize what kind of string is being passed through these options.
I mean, in general, that's a concern.
But I think
yeah, I guess you could, if your code has got some, right, okay. If you enabled some feature with, if you're trying to test a PR that you've created that's got that if you enabled one of these flags and it could potentially execute some potentially malicious code, yeah, that could be a problem. But you could do that even without turning on certain build flags, right? It comes down to the trust of the people that can initiate pull request builds. And I think that all committers can do that. And there's been a few people that have been whitelisted as well based on their past history of being able to do these things successfully and correctly.
Yep. So I don't think so. There will be a security issue because only known or trust people can only launch PR builds.
Is there a benefit to maybe just having an alias? So, we don't give the option to put whatever flags you want, but, Jenkins build debug or something.
but then the preprocessor flags don't stay the same, and you may not want to enable all the preprocessor flags, so you lose the flexibility. Because I think different files have different names as well, so it will be more challenging to accommodate a generic debug option.
I think Batmeet was trying to go for maximum flexibility here by being able to specify like any set of these options or build flags. I mean, the other potential way of doing it is if, like the alias that that Erwin had mentioned, if we maintained like a list of sort of approved um, um, flags or something that you could enable, then you could you could associate a name or a tag for each of them, and then you just specify that tag in the build.
Yep.
That way,
Yeah, and I was thinking it could even be like alias per the component. That way you don't have to deal with, like, I realize that every component has its own set of flags, but you could sort of have an alias. That way you don't have to have a crazy amount of aliases or something.
Yep. But I think the amount of work that will go in adding aliases will be a lot more than just supporting, because I think you won't be able to add support, or if I do it, I won't be able to cover the GC or JIT or all the debug flags everywhere.
Yeah.
So I think the effort.
I'm not
will
sure
be
if
a
it's
lot more.
worth. I'm not sure if it's worth it either, or we'll even get extra protection from that, because, like right now, if somebody commits some code that would potentially get run during a build that they are able to launch, like you can potentially enable some malicious code that way. So we have no way of protecting that scenario with this alias approach either. So it comes down to the trust that we put in the people that are able to launch builds.
Because I was talking more from not security, but more from just usability. I don't think there's that much of a security issue. I just think to remember, oh, I got to add it to C flags and CXX flags.
Oh, it's for convenience then.
Yeah, it's just I feel like it might be more tedious, but I mean, I'm okay either way. I already have to sometimes go and look at the documentation to figure out the exact string when I do tests sometimes. This will just add to the overhead is all. But I mean, if it's properly documented somewhere, it's probably fine.
But I know GC has configurations. I think Alex can speak more on that. Do we test for all configurations, or do we have a default one for GC? Alex, are you there?
Yeah, there are configurations for GC, but sorry, how that relates for for GC policies, how that relates to this, I'm not sure.
Because those are generally enabled via flags, right? Flags.
Which flags do you mean? Sorry.
Like those configurations enable different GC flags, right? So do we generally test for one specific one in OMR, or do we cover multiple GC configurations within OMR?
You're talking about build configurations, right?
Yep.
So not GC policies, but different build configurations for the GC component.
Which should generally enable different GC policies.
I would guess we just build one.
Okay.
Unless Alex knows differently.
Well, we have, I guess, combination of build flags but not necessarily, not really for GC policies, for platforms, etc. But I'm not sure.
Right, but as part of a pull request, would you be building multiple different build configurations of the GC?
Probably not.
That's my guess too.
Yeah.
I think that's probably true of most of the code, actually. Which it actually raises kind of a policy question that I was, or a policy point that I wanted to make in regards to this. So I think it is useful to be able to specify these flags to be able to better test a PR that has code that would otherwise be disabled in the testing. But I think we should explicitly maintain the policy that you, in order to gate the acceptance of a PR, it has to pass without these special flags there, since those flags may not be run in as part of the builds, or like they may not be the default configurations that get tested or that get used.
And in this particular case here, is the semantics are that these flags get added to whatever the existing C flags are there, or they replace the existing C flags? Probably additive is what you had in mind.
Can you please repeat the question?
Well, what are the semantics of what you're trying to achieve here? Is to take the C flags that you specify on the trigger here and add that to the C flags that's present in the make files, or is this to replace the C flags that are in the make file?
It should add them, because some of these are just disabled by default, so adding them should enable some code which should
So I wonder if
extend the coverage to them here.
Yeah, I wonder if the operator that you have here, the equal sign, if you can change that to a plus equals or something, if that would be more intuitive as to what it.
Whether it's being added or being removed. Okay.
I'm going to suggest that you create a separate issue for this particular feature, so that we can socialize it a bit and invite some discussion. I'd like to hear Adam's opinion as well on some of these things. But I mean, from my perspective, I like the idea of it. I think we just have to kind of refine it a bit to see how it's going to work in practice.
Yep, sounds good. I will open an issue for further discussion.
Sorry, I didn't mean to end the discussion. I'm just, I just wanted to.
No. I just acknowledged. I didn't want to end the discussion either, so.
I mean, I would suggest, I guess, in the issue that you I guess, put the pros and cons of the different options, like the having it this way and then having aliases and maybe anything else you can think of.
Yep, agreed.
Thanks.
Other discussion on this topic?
I'm good. So if there are no more questions or feedback, we can end it.
All right. Okay. Well, I think it's a good idea. We'll look for the issue then when it's created. Okay. All right. So that was the last topic for this week. We have another architecture meeting in 2 weeks from now. The agenda is proposed agenda is already open. So if you have any suggestions for a topic, please find that and add it. So if that's it, then we'll adjourn for this week, and we'll see you all in 2 weeks. Thanks, Mark and Babneet. Talk to you guys later. Bye.
Sure.
Take it. Bye.
Bye.